Greetings. We're going to try to do a soil profile lab. What I'm going to start with is a little bit of a review on some physical features that we've learned. First thing you need to do is download this worksheet. I've put it on in the module and we're going to fill it out as we go. So what I'm going to start with is this bottom part here. When we talked about different parent materials, we got the ones on the right-hand side there, the ones that are on the NACTA scorecard. I've got 6 samples out here. There's more than 6 samples on the right, so just put the number, write the correct name next to the sample number, or put the number next to the correct parent material. So I'm going to move over to the table. If you remember right, I'm going to have this one clear to the right. This isn't on the answer sheet, but we said that all soil originally started as rock. This is some bedrock in southern Indiana. And then we go through physical and chemical weathering to make the soil sizes, sand, silts, and clays. But the majority of the parent materials went through some massive movements and transportation, but they started out as rock and then they were changed. So, but if a soil became from weathered bedrock, that would be residuum. So if you want to put, I don't have a number on it, put sample 7 is residuum, or it started from bedrock. Now when we have bedrock rock, remember the edges will be sharp and angular. Okay, so right down at the bottom, weathered bedrocks are sharp and angular. Now, if that rock got picked up by a glacier or moved through water and moved around and then was redeposited, that rock would be smoothed out and rounded. Now remember, size has nothing to do with it. So when you have a smooth and rounded rock, put that down on that blank area in the bottom. That means it was transported by water or ice. And again, if they're sharp and rigid, they would come straight from residuum. Okay? Now, if those particles, we're going to start here in the middle with 3 and 4. If it was a uniform mixture of sands and gravels and pebbles and they're smooth and rounded, and they were brought down by the glaciers, they would get dumped, and then the soil would build in and around that mixed up gravel and stone and sand and some silts, and eventually make clays in different horizons. So sample 3, since it's mixed materials, is glacial till. Now if that glacier melted and redeposited and that material flowed out of the ice and it layered it and stratified it, which is number 4, stratified in layers. I tried to make those stratified so you got finer sands over coarser sands, over rocks, over pebbles. So they're stratified. Those were glacial outwash. So your 4 is your glacial outwash. Now, we're going to stay heavily here on Indiana soil. So after the glaciers left, we have these massive winds picked up, and then they start blowing around the materials. And if that material is silt in size, smooth and flowery, number 2 is a loess material, or a wind-blown silt. When it starts forming soil, though, it won't be little granules like that. It'll start forming different shapes and different textures. But if you break those up, they will all be silty materials, silty clay loams, plain silts. That number 2 is your wind-blown loess material. And then sample 1, I've got 2 different grades of real fine sands here. We go up in northern Indiana off of Lake Michigan and off the big, these were blown around. These are Eolian sands or wind-blown sands is sample 1. And I've got these separated. This is a little darker on the top. Not sure if you can see that. That was organic material added. So that would be an A horizon over the B horizon. Now I'm going to move on down here. Not quite as popular or well known, not much. I don't know if we have any in Indiana, but if those coarse sands from the beach were washed up and formed a beach ridge, you would have various layers of sands. And you got this one here's got organic material, so you got dark in it and then different layers. These could be 10, 20, 30, 40 inches for each one of those layers, and they'd be stacked on top of each other from the washing of the water coming up and forming a beach, and then soil forming around it. So sample 5 is a beach deposit. Now, when we look at our scorecards later today, we don't have a choice of organic soils, but remember, some of the organic soils are basically swampy areas or bogs or mucks, and they filled in with sediment materials as it fell and filled in that standing water, and they formed layers of this muck and peat soils. This is an entire profile here. We got a nice big, this nice fluffy piece here. Down below that, you get some soil starts forming, making this subcutaneous layer here. And then you got this platy structure on the top, but that's an organic soil. So 6 is your organic soil. So as a little bit of a review here, maybe I'll write these down for you. Sample 1 was an Eolian sand. So I'm gonna put a 1 next to Eolian sand. Sample 2 was a windblown loess. So I'm gonna put 2 in front of loess. Sample 3 was mixed, so that's glacial till. So I'm gonna 3 in front of till. 4 was stratified, so that's outwash for 4. 5 is a beach deposit. And 6 was an organic soil. And I don't have a number here, but make 7 residuum. That leaves us recent, alluvium, colluvial, and lacustrine. Lacustrine, if you remember, is going to look a lot like your outwash, but it's going to have a little more silt material in with that because it filled in the bottom of a lake, but it stratified that. Colluvial would be at the bottom of the hill. It could be any one of these shapes. It's whatever was at the top of the hill and slid down. And then your alluvial soils could be any one of these as far as how it looks. They have a tendency to be more like the lusses and some stratification, but that's on the floodplain. So you don't see any horizon development. So actually see a picture of those is kind of tough. Now what I'm gonna do is I'm gonna switch my camera around and we're gonna review some structures. Let me see how that looks. I'm gonna turn that a little more this way. Okay. So we're going to the top of the page now. Remember when the soils were formed, depending on where they were formed and how much clays and how many silicas and some additions and translocations, they started forming shapes out of the individual soil particles. And we called those shapes structures. I want to review those here because when we go out into the pits and we look at these monoliths, we're going to look for changes in structure to determine where the horizons are. The A's, the E's, the B's, the C's, and the R's. Now I'm going to start on the far left here. 1 and 2 are technically structureless, but they get listed with the structure types. Number 1, I'm not sure if you can see this. I'm going to slide it to the middle, but that's just pure sand. Sands don't hold any shape. So a sand would be a structureless soil, and it would be called a single grain. So sample 1, we're going to write a single grain. Sample 2 is a massive structure that you find down into the subsoil where it's been recompacted. Sediments have formed. They almost act like a rock again. So that massive structure is number 2. We won't see too much of those until we get into dense till here in Indiana, or we get some stratified sands and gravel. I'm going to go over here to my doodads that we're going to take out with this. Remember, to figure out dense material, we just drop a little hydrochloric acid, and they're both going to fizz up here. I don't know if you can see that. We did that in class earlier. That's calcareous, so that dense till in Indiana, and this is a Durapan from Texas, but those would both be massive structures. Now the ones that we're going to look heavily for today is if we take that pad and we start breaking it up and it forms little granular shapes, that usually means we're in the A horizon. So sample 3 is a granular structure that we usually find in the A horizon. So sample 3, we're going to write granular. Okay? Now, your E horizon out in our profiles under our forest will be a platey structure. It's almost inversely impossible to bring a plate in from soil. So what I did was steal some organic soil so you can see that it layers and forms on top of each other. It looks like paper plates stacked on top of each other. That's a platey structure. And if we see that, that's typically going to be in an E horizon, or if we compacted the soil from doing too much tillage, we usually can force this A horizon or this B horizon and squeeze them together, and that'll cause some limitations, and that's a plowed pan. But number 4 that is we usually see in the E horizon is a platey structure. Sample 5, we got 2 examples here, a little different color on the right. When the clays start building up in the subsoils, they're going to start forming little blocks. And that's going to be one of our keys we're going to look for today when we do a profile. When we go from a granular structure A to this blocky structure B, we have hit the subsoil. We've hit the B horizon. So those little blocks there is sample 5. Now, if you have a fairly high concentration of clays, they may form elongated blocks. In other words, they get taller than they get wide. Here's another one that's a little shorter, but they have some sharp edges on those, and they form prism shapes. So those prismatics are sample 6. I don't have a columnar, but a columnar are soils that would get high in sodium, and they would leach down through, and they would actually round off the tops and the edges of a prismatic, so it looks more like a column. Your blocky structure, we haven't moved it out here, but if they're real sharp on the edges, that's angular blocky. You don't need to write that down, but that's just a younger block. An older block, which is what normally we find in southern or central Indiana, is the water's washed around the edges and rounded those out, and they'd be called subangular blocky. So that concludes the Soil Lab preview for Profile Lab sheet. So you've got, we've done the parent materials and structures. When we get out into a pit, we're going to try to remember what those parent materials have and what those structures are, and help them make some decisions. Okay? Now, to do the next part, you need to download and run off some sheets that say Site 1, Luger Forestry, Site 2, Luger Forestry, and Site 3, Luger Forestry. Okay? Those were pits that we dug in 2017 for a Soils Invitational. Then I had these nice handy sheets, and then I made some monoliths. So I'm going to turn the camera over to the monoliths. Okay, not sure how clear this is going to be, but I'm going to show you the best I can on these, and then you're going to record some answers down on there, and then when we go outside, I'm going to get into at least one pit and walk you through this whole thing. Now, what I did was kind of imitate information that would be on a NACTA card. So what I would like you to do is get your NACTA scorecard out also. And take a look at that. It has layers here, numbered 1 through whatever. What they do in a contest, and what you need to figure out in real life is, but they give you some clues here. They're going to say, in this particular pit, we want you to find 4 horizons, and we only want you to go down to 40 inches. And we're going to put a red marker around 15 inches. And they're going to tell you how often it floods. We probably won't use that there. But what we're trying to do is today, each one of these lines would be a horizon. Okay? So I shortened it up, made it a little simpler. Instead of doing an entire scorecard, I just took a chunk off of the scorecard and kind of made up my own. I don't know if you can read these names up here, but this profile right here is our pit 1 from Luger. Then we have a pit 2 from Luger Forestry, and then a pit 3 from Luger Forestry. And we're going to record some information. And then we're also going to look at pit 4, which was at a Throckmorton contest a year later. So we won't record on there, but we're just going to show you some things. First of all, I want you to look at those and notice there's a lot of difference in these, a lot of differences in colors, a lot of differences in structures and materials that you find in those. So these are dug in a pit. These are all, I believe, 48 inches. Let me look on the side over here. Yeah, we have 48 inches in each one of these here. And what I'm going to do is imitate here is your pit 1. Excuse me, grab the wrong ones. Your pit 1, we're going to kind of help you out. I'm going to go over to my table here to get some of my doodads that we would use in a contest. What comes in very, very handy in contests, or even in the real world, is a good saw knife that you're going to dig down through a profile. And what you're going to do is try to find differences. And when you find the difference, that's going to be a different horizon. So when I start people out, I don't make them find the horizons. I tell them where they're at. The A horizon in this one stops at 6 inches, which is right about here. Okay? Now this is going to show up real clear in the camera, but if I pick up one of these pads from the top, those break right into granular structure. Then right about 6 inches here, they start forming little blocks. See that little block there? When we went from an A to the B, we went from granular to blocks. Now these blocks change, they get a little more pronounced and bigger here, okay? So in reality, this B horizon changes to another part of a B horizon, and then it changes to another part of a B horizon, and then right about here, we actually have a change in parent material, okay? So let's back up here. This surface horizon here, it tells you, okay, from 0 to 6 inches, what is the texture? So if I take a sample out of here, I don't want to take too much because I'm going to leave this for future. Whenever you do a texture, you're going to crumble it in your hands. I'm going to find a plate to catch this in. What did I do with my plate? I'll be right back. I don't want to mess up my monoliths here. So I've got these pretty moist already. But I can tell right off the bat, I've done a lot of these, that's pretty smooth and mellow. And if I start getting that wet, it's going to hold together, stick a little bit. What you need to train yourself is what is sticky and slimy and just holding soil together. This isn't sticky and slimy. If I do that thumb imprint, I don't get that shine and sheen. It forms a fairly smooth, mellow ribbon. Okay, does anybody remember know what that texture would be? Smooth and mellow, not slimy. That texture would be a silt loam. So you put S-I-L. S, capital S, little I, big L for silt loam. That structure, we played around with, that's granular, so we're going to put GR for granular. And then when we do color, remember we do that with Munsell. So we're going to grab a Munsell. And we're going to find the chip that lines up the best. I'm hoping these show up halfway decent. I'm going to call it that chip right there. So that's a 10YR 4-3. So let's record that, 10YR 4-3. Make sure you put the 10YR. Now models, what that is do you see two-tone colors anywhere in this? In other words, do we see both grays and browns? Okay, the answer is yes. I don't know if you can see that. there's some lighter colors and some darker colors, okay? Now, when we get down to drainage, that's gonna be a tough call here, because remember, two-tone colors, if we got grays on browns, or browns on grays, or browns on browns, okay? So we're just gonna say, when I start people, I say, can you see that there's two colors? And I would expect you to say yes. Excuse me. In the A horizon, 0 to 6, I'm sorry, I'm messing up my own sheet. There is no modeling, no changes in color in the top 6. They're all uniform the same color. Okay, now I'm going to tell you this first B horizon is going to start here about 6 and go down to about 24. When we get to 24, we're going to change parent materials in here. Okay, so let's look at this top parent material. We're going to do the same thing. And we're going to grab one of these samples here. And I'm just going to need some place to dump my soil as we go. So again, I'll be right back. I didn't bring enough stuff. I'll use this for a refuse over here and kind of put this plate in the middle. Now this one here, as soon as I grab it, I can kind of start feeling that slime a little bit. So I'm going to put my water on there. I'll try to walk it closer to the camera here. See that starts shining up there. And then I do my thumb indentation, it gets that little slimy. And if I work all this moisture in here, it's going to form a halfway decent ribbon that's got some strength and shape to it. My hand's a little too wet. See, that's got a fairly strong ribbon. That, if you remember, is a silty clay loam. And while I got it, it's going to be a little browner and a little lighter up here. Okay? So I'm going to call it a 10YR 5-4. So we got a 10YR 5-4. Remember, you got to keep your hands clean. So I'm going to get my hands wet here a little bit and clean that up. So that was a silty clay loam. So we're going to do capital S, little I, C, L, because it was sticky and slimy. That was a blocky structure. I forget my key on blocks. So I'm going to look at my knack card and cheat. Got too much stuff here. Oh, I saved the knack card out. Now to help you guys out, if you've got your knack card, if you look under structure, it has, or texture, I'll get their structure, it has all the abbreviations. So this one's got rounded edges, so I'm going to call it subangular blocky, so SBK, all capital letters. SBK, and that was a 10YR5. Does anybody remember what it was? I already forgot. 10YR something. 5-4. Now, between 16 and 24 inches, now we can start seeing more than one color. So yes, there is modeling. Okay? Now, in the contest, the NACTA card, you'll flip it over and it'll say, find up to 3 parent materials. So what we're going to do here is I tell you where to look. From 12 to 20 inches, what is the parent material? So into this B horizon, all the way down to about here 20. Now we're going to review what we did over there. We're going to play a little bit of Dick Tracy or CSI, and we're going to look for pebbles and rocks. If I pull that apart, it's all smooth and mellow, excuse me. No pebbles and rocks down to 20 inches. So that parent material would be Loess, L-O-E-S-S. Now when I get to 24 to 36 inches, that's down here, we start seeing pebbles and rocks. There's some big ones and there's little ones, and they're all rounded and smooth, and they're uniformly mixed throughout from here all the way down. So when the pebbles and rocks are uniformly mixed, that's glacial till. So parent material between 24 and 36 is glacial till. Now, slope is the angle of the surface. I'll try to demonstrate that outside with a clinometer. Let me think here. Site 1 at Richard Luger, that was 0 to 2%. Okay? And then what I force you to do is, okay, let's figure this out. We're going to look for some calcareous material, which means we take our hydrochloric acid and just go down the profile and see if anything starts fizzing. Which there is none. So I went all the way to 48 inches, and it says calcareous. Since we didn't find any, you're going to write greater than 40 inches or 48 inches. Okay? Now, natural soil drainage class, let's review that a little bit. All browns, well drained. Gray colors, poorly drained. Mixture of colors like we got here, grays and browns, or two-tone colors, I should say. You got to decide if these are grays or not. So that little peg right there, I'm going to open that thing up. I've definitely got a gray and a brown mixed. This gray and this brown mix is between 18 and 30. No grays above 20 inches. Okay? Now, we'll review those here in a little bit, but that meant moderately well drained if your grays are below 18 inches, 18 to 30. 10 to 18 is the other zone. They're all browns down to there. If it continued to be all browns, it would be a well-drained soil. So our natural soil drainage is moderately well. I'm just going to put MW. Comments on the soil profile, 2 parent materials. Now, when we get into the NACTA cards out there a little bit, what you would have to do here is you would have to determine, if I said there's 1, 2, 3, 5 different horizons, I would have to give you a reference point. I got, don't have a red one, but I have a white one. Here's the A, here's the first B, this is the second B, so you stick that in the 3rd horizon. Don't know if you can see that, don't write this down, this is kind of getting you ready for when we go outside. So in an active contest, if I tell you that there's 5 horizons, you know that this is the 3rd horizon, somewhere above and below that is the 3rd, and you need to find 2 divisions above this. And by telling you that, we definitely found a clear division. Now color, not a big color change here, but definitely going from granular to blocky. So we would say the first horizon is an A horizon. We would say the second horizon would go from 6 inches down to about 12 inches, and we call that a B horizon. And then from 12 down to about 20 is another B horizon. We changed parent materials, so we got a different B horizon. 20, see 1, 2, 3. So now I just know I gotta find 2 divisions between here. There's actually more, but since I told you that there's only 5, you find the most obvious change, and that's right about here where this pebble or this rock is, because these definitely get to be larger blocks. So then we'd have another B horizon from 20 to 33 inches, but this B horizon would have a number 2 in front of it, because we have pebbles and rocks, so that's a 2B, and then below that would be another 2B. Now, if you're really good and you go the 4-year, we'd have to put the subtitles on those, where we'd have B2s and BSs, but we're not going to get into that. So that kind of helps you out there, or hope makes sense. So that would be pit 1. So let's switch to pit 2. Here, let me see. I don't know if this will show. I'm going to come show you pit 1 answers. I'm going to come stand behind the camera so I can get this centrally located. So there's what you should have wrote down. SIL for texture, GR for granular, 10YR43, no models. Then your 6 to 24 was SAICL for silty clay loam, subangular rockly, SBK, 10YR54, and yes, you saw modeling. When you dug down to 20 inches, no pebbles and rocks, smooth and mellow, so that's all silty material, so that's Luss. When you hit 24, you started finding little rounded rocks and pebbles that were uniformly mixed, so it's glacial till. The slope I'm just going to give you, it's pretty level, 0 to 2%, and we didn't find any calcareous zones, and we didn't find any gray models till at below 18 inches, so it was moderately well drained. Okay? So that took about 30 minutes, so I think I'm just going to speed it up on the other ones, and we're not going to worry about writing anything down. How's that sound? So pit 2, very similar, okay? We're going to talk about 0 to 6 and 6 to 12. And I gave you a little clue there. This thing was on like about an 8, if I remember, about an 8 to 10% slope. So we're starting to pick up some angles. I'm gonna write my answers down, but you don't have to. We were on the side of a hill here, and that kind of tells us, well, maybe we had erosion. The way you can tell you have erosion is if your first structure you find are little blocks, like I've got here, there is no granular, no horizon. In reality, if you look kind of close here, this one was right before you went down the hill. Then this one is on the hill on the backside. This particular soil here and this one about here are real similar in their makeup. This one just lost its surface soil. So we start with a B horizon, no A horizon, little blocky structures. If I pull that out, that would be that sticky, slimy, and that would be a silty clay loam. And you go to the next layer there, 6 to 24 inches. So right around about 6 to 24 inches, we start playing with that. We definitely get these bigger blocks. Those get real slimy. I mean, don't put that back on the thing. So if I play with those, we definitely get another ribbon. So that'd be another silty clay loam, a little stickier, but not enough. We start picking up these round rocks. So from here on down, it's glacial till, just like the bottom of this one is here. Now we get to the very bottom of this one, we might see some grayish colors, but those are all below 30 inches, so we have no modeling. Down to 30, all the water runs off the top. No drainage issues here, so that would be a well-drained hole. And our colors, your top here, looks like about a 10YR43 over, well, let's just look at this one. Oh, crap. Muscles over there. And we got about a 5.3 down there in the subsoil, okay? This was one that was actually in there, smooth and rounded. Again, that had been moving water, rounded pebbles, so you got glacial till. Again, don't worry about writing all these down. I'm just gonna give you the one that you gotta fill out, which is pit 1. No calcareous, well, this one possibly could have some calcareous materials. Probably should bring my doodads to this side of the table, so I'm gonna keep running back and forth. With calcareous, possibly down here, almost, no, not quite. While we got this out, let's check out pit 3. Do we have any calcareous materials? Starts fizzing right there, okay? Well, I got that out. If we pull these out, that's that dense till material. So this hole right here, pit 3, we hit dense till. Okay? But this one's a well drain. So you got an A horizon, no A horizon, you got a B, another B that goes to about here, and then another B to here. Several B horizons because they changed in consistency. We have a loess on the top. There's no pebbles and rocks. From here on down, it's glacial till. So you got loess over till. This one was loess over till. You move to pit 3. I need to describe this one a little bit. This is after you've gone over the hill, you walk back up over the hill and you start heading back towards the buildings, and you hit this flat area and you walk down into this little bowl, like this little depression. So pit 3 is sitting in the bottom of this little bowl, okay? And what we start telling our kids when they're learning how to do soils, little depressions that are flat have a tendency to be deep, they have a tendency to be dark, and they have a tendency to be poorly drained. And this one has all of the surface layer, definitely a dark layer, stops down there so your aerosion has been washing in from the surrounding areas. You go to your blocky structures here underneath. You go down deep enough, you are going to find some rocks and pebbles. So you got a loess over a glacial till, and then that till got compacted or dense. So this would have a limiting layer at pit 3. Let me see if I made you look at that on the answer sheet. Yeah, I would expect you on the comments there. We've got calcareous material. That would stop root growth right about in here. So that would be dense till. I'll have to come over here at about 39, almost 40 inches. So on Indiana contest, if you decided that was greater than 40, you're going to mark something different than if it was 20 to 40. But what I want to talk, that's one key thing we'd like you to learn on this one, this compacted zone, calcareous. Now this zone here, you just kind of need to train your eyes. I don't know if I can pick this up and put it back, but we're going to try it. Nope, it's going to fall apart. So, can you see these little black buckshots? It's got that olive greenish grayish tone to it. That's a soil that is poorly drained. When you get those gray colors, predominantly gray colors, we've got 10 inches more dark, so our diagnostic zone changed, definite gray material in here. That's a poorly drained soil. So on this side here,